Ladies and gentlemen, welcome back. It is the final video that we're going to be doing here with Chapter 6, where we are looking at the normal model. And in this video, we are going to be looking at how to find percentiles and z-scores that is more than just what we can see on the 68, 95, 99.7 rule. So in the last video, we learned about how on a normal model, we've got the center and we've got these standard deviations that go out. And that the general rule is that within one standard deviation, it's 68%. Within two standard deviations, it's 95%. And within three standard deviations, it's 99.7%. So we answered some questions that were exactly 1, 2, or 3 standard deviations away. However, that's not how the world works. The world never works exactly 1 standard deviation, right? That is a very rare occurrence, in fact. So we need to be able to look at how to find these percentiles when it's not a perfect thing, okay? So when it doesn't fall exactly as 1, 2, or 3 standard deviations from the mean, we can look it up on the table of normal percentiles. Now, any statistics book you have is going to have a bunch of tables in the back of the book where you can look at these normal percentiles. However, most calculators and statistics computer packages provide these as well, and that's what we're going to concentrate on in this video, mostly because people don't generally use those tables anymore, right? We live in the 21st century, and we have technology that assists us with this. So that's how we're going to be showing it in this video, is using that. So using technology, there's a couple of different commands that you can use. This Active Stats Media Assistant, there's a normal model tool that you can use. If you're using a TI calculator, there's a command called NormalCDF, which is what we're going to be looking at, and we'll do it within the example that we're going to do. This is a TI-84 and a TI-83. They have the same kind of commands on other types of calculators, but again, I'm going to focus on the TI calculators since that is the most common one. So the overall goal here of what we're trying to do is to find these areas in between the number of standard deviations. So here we've got an example of a picture of a normal model that is between negative 0.5 standard deviations and 1 standard deviation. So this is what we're gonna. This is the kind of the picture of what we're going to be finding with the technology is when we have z-scores that are falling in between. Can we find the area beneath the normal model curve to be able to find that percentile? So let's do an example here. Okay. So suppose a normal model describes the fuel efficiency of cars currently registered in your state, the mean being 24 with a standard deviation of 6. This, by the way, means we have a normal model of 24,6, right? Just to recall from last video. What percent of all cars get less than 15 miles per gallon? So again, the first thing we're going to do is draw a picture of the situation because this is what we always want to start with. Making a picture helps us make sense of things. The mean is 24, and then our standard deviations are 6. So this is 18, 12, and 6. And then this other direction is 30, 36, and 42. We are looking for less than 15 miles per gallon. So let's highlight the area that is less than 15. So 15 is about right here, right? If this is 18 and 12, that's 15. So that means we're looking for this area over here, okay? So let's back up and look at the technology. So here we have, on the left over here, this is the TI-84 calculator. And what we're going to do is use a command called NormalCDF. So the place, oh, I've been logged out. I don't know why that needs to go away, but I can't make it go away because this thing's here. Sorry. All of these things. Go away. Okay, we're back. Okay, let's try this again. So we're going to use a command called NormalCDF to make that happen. And the NormalCDF command is under this distribution menu, DISTR. So it's in the second area. So you hit second, vars. Now, there's a number of commands in here, many of which that we will use throughout the year. There's NormalPDF and there's NormalCDF. What we're looking for is NormalCDF. So PDF does something different. We'll explain that at a different time, the difference between PDFs and CDFs. So NormalCDF is looking for a couple of different things. We are basically telling the command that we need to go from the bottom to the top. We're going to tell the command to give us an interval. So we have NormalCDF, and some calculators will bring up a wizard that say lower bound, upper bound. This one doesn't. So what we're going to give it is a lower bound. So we're going to tell the calculator how far to the left do we need to go. Now, this goes on for infinity. So what we're going to do is just we're going to give it a very small number. So we're going to call it -10 because that's a number far over here. Now, what we need to do on this side is give it the z-score for 15 miles per gallon. So we need to find the z-score for 15 miles per gallon. So my z-score formula is going to be 15 minus my mean of 24 divided by my standard deviation, which is 6. So this is, what is that, -9/6, which is -3/2, right? So the second part of my command is start over here at -10, and then that's my lower bound, and then come all the way here to -3/2, or -1.5, and then it's going to tell us what this is. So let's go ahead and enter that, right? -10. We're going to do a small number for the lower bound, and then -1.5 for the upper bound, and there it is. That's my percentile. That is 6.6%. So this is 6.6%. So what percent of all cars get less than 15 miles per gallon? 6.6% of them do, because the z-score for 15 miles per gallon is -3/2, and the percentile from here all the way over, and again, I just chose a very small number for this side, is 6.6. So the area beneath this curve is 6.6%. Let's do the next one. We're just going to leave it on this same page. We'll clear this out. So what percent of all cars get between 20 and 30? So we're going to draw a different graph this time. 24 is the center still. This is still 18, 12, and 6. But now we're going between that 20 and 30. So 30 is here. 20 is about there. So now we're finding this range inside. So again, we're going to tell our calculators to do the lower bound here and the upper bound here. I need to find z-scores for each of these. So 20 minus 24/6 gives me -4/6, or -2/3. And then 30 minus 24/6, that actually should not be surprising to me because that's 1. 30 is on there. Now I need to go to my NormalCDF command, NormalCDF, and I need to give it a lower bound of -2/3, and I need to give it an upper bound of 1. So I'm telling the calculator, start counting at -2/3, and then count the area under the curve until you get to 1. So let's do that. We're going to just bring up my NormalCDF command that way. Actually, let's show it again just in case. Distribution menu, second, vars, NormalCDF. -2/3 is -0.66, right? We don't need to be perfect on that one. Actually, I think I used the wrong. There we go. and then comma, my upper bound, which is 1. And there it is, 0.5867. So 0.5, where we can say 58.7%. So how many cars get between 20 and 30 miles per gallon? 58.7% of them do. Again, I found the z-scores for 20 and 30, and then I used the NormalCDF command to give me a lower and upper bound for those pieces. Let's do this last problem now. What percent of cars get more than 40 miles per gallon? I'm just going to steal this picture again. So we're talking about more than 40. 40 is about here, so we're looking for this area over there. We can tell that this is going to be a very small number from the picture. I need to find the z-score for 40. 40 minus 24 divided by 6 gives me 16 over 6, which is 8/3, okay, or 2 2/3 if you want. So there's my z-score. I need to use my NormalCDF command. And again, I'm doing a lower bound and an upper bound. So in this case, I want it to start at 2 2/3. So 2.6 repeating is my lower bound. My upper bound is forever, right? It says get more than 40. So it's all numbers greater than 40. I can't put infinity into this, but I can just put a very large number. In this case, 2.6 standard deviations is here. I'm going to choose 10, right? 10 is a large enough number that it's not going to make a difference. So we enter that into our calculators. Second, vars, NormalCDF, 2.66, and again we can round, it's not a big deal here, and then with an upper bound of 10 gives us, see, a very small percentage. Like I said, this is a 0.39%. So what percent of all cars get more than 40 miles per gallon? 0.39% of cars get more than 40 miles per gallon in that area. Very small amount. So this is taking a percentile, or excuse me, taking a z-score and finding a percentile. So we're going from z-score to percentile. Now, we sometimes need to go the other direction. So let's take a look at going the other direction. What did I do? There we go. Try this again. Let's take a look at going the other direction now. So that's that page. Great. Oh, I'm going to skip that last problem. So from percentiles to scores, now we're going to go the reverse, right? We're going to start with a percentile, and we're going to go with the z-score. So sometimes we start with the area, and we need to find the corresponding z-score or even the original data value. So we have this picture down here. This normal model picture is saying we have 25%. That's what I'm looking for. What I need to find is this z-score. Like, I can tell that it's about maybe 0.67 or maybe 0.75, somewhere in there. But I need to find this exact one. This is the lower 25% of the distribution, but I need to find the exact z-score that is associated with that lower 25%. So we're going to go in the reverse direction now. Let's look at an example. So again, normal model for gas mileage. We're going to do 24, the mean is 24, the standard deviation is 6. Describe the fuel efficiency of the bottom 20% of cars. So again, I'm looking at the bottom 20%, which is going to be around here somewhere, right? Bottom 20%. And what I'm looking for is the z-score associated with that particular thing. And again, we're going to go back to technology to check this out. So let's go back to our calculator. There's a different command that we use for this one. The command that we use to figure this out is called inverse norm. Inverse norm. And the only thing that we need to put in as a command for inverse norm is percentile. Now, some of your calculators are going to show a wizard that has the mean and the standard deviation in there as well. You're going to want to use 0, 1. You can use other ways to do it, and you can kind of explore that by yourself. But we're going to find the z-score, which means that we need to use a mean of 0 and a standard deviation of 1. So let's go to the calculator and do that so we can find that z-score. So second distribution, inverse norm. It's right below normal CDF, so it's doing the opposite. And I need to put in the percentile here. We do it as a decimal. Oops, I hit the wrong button. Let's try that again. Inverse norm, 0.20, and enter. So there it is. That is my z-score. So my z-score is negative 0.841. Oops, that should be an equal sign. And we can tell from here, so now we were asked to describe the fuel efficiency of the bottom 20% of cars. We have the z-score associated with that, but now we need to play with our z-score formula to actually find the actual gas mileages. So we don't know the gas mileages yet. So we're looking for y. Negative 0.84, that's my z-score, equals y minus my mean of 24 over 6, my standard deviation. Now we just need to solve this equation. Multiply both sides by 6. So I need to, I can't do that one in my head right now. So negative 0.84 times 6 gives us negative 5.04. So that's negative, oops, I get to my pen. So that's negative 5.04 equals y minus 24. And then we need to add 24 to both sides to get what my y would be. So this is negative 5.04 plus 24 is 18.96. And that is my solution here, 18.96. So what's the fuel efficiency of the bottom 20% of cars? It is 18.96 and under. 18.96 is 20%. So every gas mileage beneath that is going to be your the lower 20%. Let's do the next example. What gas mileage represents the third quartile? So here we're being asked for a quartile. And so we have to remember, well, what is the percentile represented by the third quartile? And that would be 0.75. So now I need to find the z-score associated with 0.75. So again, there's my inverse norm command. I'm going to go back over here, and that's second vars down to inverse norm. And my percentile is 0.75, so 0.75. And that gives me 0.67. So 0.67 is my z-score. We need to find the actual gas mileage, so let's play with my z-score formula. 0.67 equals y minus my mean divided by my standard deviation. I need to multiply both sides by 6 and add 24. I'm not going to go through and show the whole steps of the solving equations this time. I'm just going to multiply this by 6. And then I'm going to add 24, and I can see that the answer for the third quartile is 28.04. So what gas mileage represents the third quartile? 28.04. I found the z-score associated with 0.75 by using inverse norm. And then I plugged that z-score with my mean and standard deviation into my calculator, or excuse me, into that formula, and I solved for y to get 28.04. Okay, next example. What is the interquartile range for the gas mileage? So interquartile range is the difference between 25% and 75%, which means I'm going to need to find z-scores for both of these, convert them both to gas mileages, and then subtract them. So let's do it. We're going to find the z-score for 25%, which is it's negative 0.67. I can tell you guys that right now, and I'll tell you why I know that. What happened? Oh, I'm using the wrong command. 0.25. So yeah, negative 0.67. I just wanted to show you on the calculator. This is negative 0.67. We found in the last example that that's 0.67. I know that this is going to be the opposite of this, because if you think about how a normal model works, if 25% over here is 0.67, it is symmetrical. So the 25% on this side will make it to negative 0.67. So just a little, make it a little bit easier tip. Let me show you another little bit easier tip. If we want to do this whole thing in that whole solving your calculator thing, you can do that on your calculator also. Again, I want to make sure that you know how to do both, but let's go ahead and show you how this works. If you go to inverse norm, plug in 0.25, and then plug in the mean of 24 and the standard deviation of 6, this will actually do that calculation for you and make this 19.95. So we can do the same thing with 0.75. Again, I'm doing a bit of a shortcut here to give us straight to the gas mileage without having to plug into the equation. Again, it's important knowledge to be able to do both. But here's a nice little quick thing for you. This is 28.04, which I guess technically we knew because that was the answer to the last question. And then if we want to find the actual interquartile range, we'd better subtract those two. So then we're going to go 19.95, 30615. And so there's my interquartile range, 8.09. All right, and that's where we're going to call it for this video. So this is the end of Chapter 6. It's actually the end of Unit 1, talking about the normal model. Finding z-scores and doing this stuff in reverse is a really important concept for some things that we're going to be doing later on in this the course. So if you've got questions, again, please make sure you can leave a comment here, or make sure you seek me out so we can talk about it. All right. Thank you very much for watching, and I hope to see you guys in the next chapter. Thanks.